Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of Coulomb's law. Coulomb's law is basically a introduction to electrostatic forces. We talked about contact forces like friction or pushing or pulling, tensions and stuff like that. But these electrostatic forces can be felt at a distance. And Coulomb came up with the relationship between the force and its inverse proportionality to the radius squared times the products of the individual charges. Okay, so here's the actual law where K is this constant here, 8.99 times 10 to the 9th newtons per meter squared over Coulomb squared, which equals 1 over 4 pi epsilon naught, where epsilon naught is permittivity constant of free space or vacuum. So the SI unit for coulombs is going to be 1 coulomb, named after the scientist himself. Roughly, and the charge of an electron is 1.602 times 10 to the negative 19 coulombs. We use absolute value because you should always have a positive magnitude for forces. Since it is a force, it should be positive. So we can deal with signs. If we have like signs, we should know that the like charges repel each other, whether they're both negative or whether they're both positive. If we have opposite charges, they will attract. And when you have multiple charges, we're going to use superposition principle and vector math. Okay? So let's consider this scenario, just as an example, in which we have Q1 equal to Q2, and Q3 is located at some distance d away on the perpendicular bisector of this line here, meaning that A1 is equal to A2. If that's true, then B will equal B, right? These two hypotenuses, and the thetas will equal each other. So here we're going to have negative charges indicated by the blue and a positive charge here. So the net force that 1 will have on 3 is it'll pull 3 towards the 1. 2 will do the same thing. So when we look at the force diagram, it would look something like this. And you should note that because Q1 and Q2 are the same distance away from Q3, and because they're the same magnitude, their y components will cancel out. Okay? This 1, 3 will be exactly the same as this 2, 3 force. And what happens is when you break down your force into the x and y component of your vectors, which you can take this guy and actually look at it as if it was right here for the y. That was horrible. So just use basic trig. All right. Sometimes you'll be given the distances. Sometimes you'll be given the angles. So here's an example. If I was looking at force 1, 3, which is this one right here, I could break it down into the x component and the y component. And I already told you the two y components are going to cancel each other out. So we only have twice the two fx's is what we have. So if we find f sub x, we can multiply by 2, or find each individual f's of x and then add them together. You'll get the same answer. So how do I find f sub x? Well, the x component of the force is the adjacent leg of this theta, and you go over the hypotenuse, which is the actual force, so adjacent over hypotenuse, and then you multiply both sides by force 1/3, and then there's the expression for the x component. So given some theta, or if you were given a and b, you could calculate this, or you could be given this distance. There are many ways they could ask that question. It's essentially the same question. You'll need to find the x component, double it. All right? So that's just a peek into it. I'll do a few examples of charge distributions. And then make sure you check out those example videos. And after you feel familiar with the force, you will look at the electric field, which is a force at a distance. If you were to place a test charge, a positive test charge somewhere, what force would it feel from a nearby charge or charge distribution? I hope I've cleared up any confusion you might have over Coulomb's law. Practice, practice, practice. Thank you and have a nice day.